Let's take a look at number 15, number 17. Unfortunately, I can't bring up the one you're actually seeing because it comes up just a black screen for some reason. But this should give you the idea of how to solve it. We got x squared plus 14x plus 49 over x squared minus x minus 30 is less than or equal to 0. This is a rational inequality. Rational means single fraction. And the first step is to get 0 on one side, which we have. Our second step is to get a single fraction, which we have. We then need to factor everything. So the top part factors as x plus 7 times x plus 7. The bottom part factors as x minus 6 times x plus 5. We then want to set each factor equal to 0. So we'll set x plus 7 equal to 0. Now I don't need to set the other x plus 7 equal to 0 because they're the same. I'll set the x minus 6 equal to 0, and I'll set the x plus 5 equal to 0. And we want to solve for x. So we got x equal negative 7, x equal positive 6, and x is equal negative 5. Okay, so now we want to build a table of intervals. Here's negative 7, that's our smallest number. Negative 5 and 6. Now clear over here is negative infinity, clear over here is positive infinity. We want to pick test cases that fall in each range. So something between negative infinity and negative 7, like negative 8 or negative 9. Doesn't matter what you pick. Something between negative 7 and negative 5, like negative 6. Something between negative 5 and 6, like 0. And something greater than 6, like 7 or 8 or 10, whatever you want. Now we want to plug these into our inequality. Now I'm going to pick this one because this is a little bit simpler than this. Okay, so if I plug in negative 8 for the x, we're going to have negative 8 plus 7 times negative 8 plus 7. And we'll have negative 8 minus 6 and negative 8 plus 5. Negative 8 plus 7 is negative 1. Negative 8 plus 7 is negative 1. Negative 8, negative 6 is negative 14. Negative 8 plus 5 is negative 3. Now a negative times a negative is a positive, and negative times a negative is positive here. And a positive divided by positive is positive. Now the question is whether these are less than or equal to 0. Well, less than 0 means negative. This is positive, so this is not part of our answer. So from negative infinity to negative 7 is not part of our answer. So we'll plug in negative 6. So we're going to have negative 6 plus 7, negative 6 plus 7. We'll have negative 6, and negative 6 plus 5. Negative 6 plus 7 is 1. Negative 6 plus 7 is 1. Negative 6 is negative 12. Negative 6 plus 5 is negative 1. Now 1 times 1 is positive. Negative times negative is positive, so this gives us a positive. So this is not part of our answer. Now if I plug in 0, let me double check that, but it seems weird. Negative, that's positive, okay. That's positive, okay, that's checks. If I plug in negative 6, yeah, sure enough. Okay, if I plug in 0, I got 0 plus 7, and 0 plus 7. And here I'll have 0 minus 6 and 0 plus 5. Now all we really care about is the sign, so keep that in mind. 0 plus 7 is 7, 0 plus 7 is 7. Positive times a positive is positive. This one's negative 6. This is positive 5. A negative times a positive is negative. So this gives us a negative, which is less than 0. So this is part of our answer. Now over here, if I plug in 7, I got 7 plus 7, 7 plus 7, and 7 minus 6, and 7 plus 5. 7 plus 7 is 14, 7 plus 7 is 14, positive times a positive is positive. 7 minus 6 is 1, which is positive. 7 plus 5 is positive. Positive times positive is positive. So that gives us positive, so the answer here is no. So our only interval is from negative 5 to 6. Now normally, since this is a less than or equal to, there's a line underneath, the equal part. That means put brackets. But any answer that comes from our denominator always has to have parentheses on it. So our answer would be negative 5 to 6. Now in the calculator, if you got TA3, TA4, if you go to y equals clear and you plug in this fraction, put in parentheses around top, parentheses around the bottom. I'm going to have x squared plus 14x plus 49, closing parentheses, divided by beginning parentheses, x squared minus x minus 30, and then graph. Okay, yeah. This is going up here forever, just stops. Kind of threw me for a minute, but I look, well, this is a T84 Plus. I shouldn't be saying that. Looks better on newer T84s. But you can see where our graph is below. That's what less than or equal to 0 means, below the x-axis, is from negative 5 to positive 6. So that confirms what we just saw there. Now that's another way you can do these, is you can look at the graph and you can look to see if it's less than or less than or equal to, you're looking for below the x-axis. If it's greater than or greater than or equal to, you're looking for above the x-axis. So this is our answer here, and then you'd plot that. Now I won't work number 17 all the way because it's the same idea, but I'll get started with it. So let me clear this off. Okay. Number 17, we got 5 over x squared minus 1 is greater than 1. First off, you have to have 0 on one side. So I'm going to take that 1, move it over. So you got 5 over x squared minus 1. The positive 1 becomes a negative 1, greater than 0. And this becomes negative 1 times x squared minus 1 plus 5 over x squared minus 1. Rational means we have to get a single fraction. So what you do is you take your number to the side, you multiply it times your denominator. You add your numerator, and then your denominator stays as is. Negative 1 times x squared is negative x squared. Negative 1 times negative 1 is a positive 1, plus 5 over x squared minus 1, greater than 0. That gives us negative x squared plus 6 over x squared minus 1, greater than 0. Take that over there, multiply that. Okay, negative 1 times x squared minus 1 plus 5 I'll factor the top, factor the bottom, so I'll factor negative 1 out. This factors as x plus 1, x minus 1. I'm going to go ahead and continue with this. Now I don't need to set negative 1 equal to 0, but I'll set the x squared minus 6 equal to 0. I'll set the x plus 1 equal to 0, and I'll set the x minus 1 equal to 0. Now this is a square root property. Take negative 6 over, becomes a positive 6. Drop the squared, put a plus or minus square root on the other side. Here I'll take negative 1 over, and here I'll take a positive 1. So our smallest value is the negative square root of 6. Our next one is negative 1, then x equals 1, and then x equals positive square root of 6. Clear over here is positive infinity, clear over here is negative infinity. I'm going to plug this in my calculator. Point where you want to plug in the calculator is where you have a single fraction on the left side. And this is the easiest one right here. So put parentheses around top, parentheses around the bottom. I'm just wondering how in the world you can actually determine where square root of 6 is with the primitive tools you have. That's what my confusion is and why I'm going further. But maybe they're not part of our answer, so maybe it doesn't matter. Okay, let me do a graph now. Now, this is greater than 0, so we're looking for it's above the x-axis. Okay, I'm assuming this is negative square root of 6 here, and it's below over here, so that's fine. But then I notice it's above here. That would imply that this is our answer. Now from negative 1 to 1, here's negative 1 to 1, it's below, so it's down here. But then from 1 to square root of 6, I see it's above. Interesting. So our answer is negative square root of 6 to negative 1, and 1 to square root of 6. Now it's a greater than, which means everything's parentheses, like this. Now on the graph, since it's asking us to graph it, you would change these to decimal form, square root of 6, and get as close as you can to what you think it would be. If it counts it wrong, let me know. Square root of 6. So little bit less than the halfway mark on that. But this would be your what you graph.